We're going to look at an example found on page 199. There's a couple who wants to have 3 children, and they would like to have at least one boy and at least one girl. So what is the probability that they'll get their wish, assuming they have 3 children, that at least one will be a boy and at least one will be a girl? In order to figure this probability, we need to know how many different outcomes are possible. We can use a tree diagram to find that out. If you turn the page to page 200, number 1, you see the beginnings of a tree diagram started for you. Their first child could be either a boy or a girl, and then given that first child, their second child could be either a boy or a girl. Then given their history, the third child could be either a boy or a girl. So this tree diagram is a great way to explore and map out all the different possibilities. So pause the video and fill in the chart. So now that we have our chart filled in, we can go through and see all the potential outcomes. Each branch of the tree represents a different outcome. They could be 3 boys, 2 boys and a girl. I've mapped out just one example, boy, girl, girl, and I believe they already have that for you in the book. So pause the video again and go ahead next to each final branch, write down what the overall outcome is that represents. So remember, you're starting at the beginning with each one and you're tracing the path necessary in order to get there, and then you write whether or not each one was a boy or a girl in order to end up in that spot. So pause and try it. Is this what you have? So this list of all possible outcomes actually is the sample space. On question number 2, they want you to write what the sample space is. So you can write that with our set notation. Let's see if we can get it to work. Maybe. So we just list all of them. Remember, with the sample space, it doesn't matter what order you write them, just as long as you get them all in there and you don't repeat anything. So it's good to have kind of a systematic way of putting them down, and just working your way down through the tree diagram is a great way. Boy, 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 girl, and so on. You can go ahead and press pause and finish that. Now when you're listing your sample space, you can double check and make sure that you didn't forget any of them by counting, and make sure that you have 8 entries. Question number 3 wants us to find the probability of exactly 2 boys. So we know that when we're finding theoretical probability, the number on the bottom is the total number possible, so 8. Now how many of those 8 are exactly 2 boys? Now let's see. There's that one, that one, that one, and that's it. So 3 out of 8. You could leave it 3 out of 8, or you could give a decimal approximation. Actually, you could give an exact decimal for this one. Either one would be fine. Number 4 asks us for the probability of at least 2 girls. Now, at first we might think, oh, well, this is just the same as the last one. We're just doing girls instead of boys. But it's not. Do you see the big difference? This would be different even if it said at least 2 boys. The difference is this at least. That's different than exactly. At least means it could be exactly. So exactly 2 girls, exactly 2 girls, exactly 2 girls, 3, just like before. But at least means that there could be more than 2 girls as well. So also this one. So our probability in this case is 4 out of 8. Or if you want to, you could reduce. You could even write it as a decimal, or you could write it as a percent. Okay, so now we get to number 5, where we answer the question we began with. What is the probability that they will get their wish, that they will have at least one of each? So let's see if you understand what we've just learned. Pause the video and answer number 5, and then unpause, and you can compare your answer. Now you'll notice the strategy that I used. I thought, well, it'll be a lot faster to just subtract the ones that don't qualify. There's only 2 of them, all boys or all girls. Otherwise, the rest of them, 8 minus 2 is 6. There are 6 different options that fulfill what they're looking for. And you'll notice that we've got all these different ways that we could write the answer. These are all mathematically accurate, and I'd take any of them. Now finally, don't forget to answer number 6. You're supposed to describe how being able to count different possibilities helps us in computing probability. So being able to figure out what all of these outcomes were and how many of them, there were 8 of them, how did the number 8 come into play in all of these questions? Those are things you might think about as you give a short but complete answer to number 6.